anything special on the demo side, feel free to ask anything.
Okay.
Sorry, no problem. Great. And then this portion is a kind of schematic of how the capturing or the identification can work in certain setup. We start with academic center a lot, but we see more and more academic mixed clinical utilization, and especially with the machine learning model and those training model, then we can leverage the fact that we can use old data that are available. It's real also for pharma company and other company that they have tons of data that never been used in the past, and suddenly say, oh, you know what? Maybe we can get that data, cure that data, and get organized to use this data. Then that's, and what is interesting also in our platform, even this is a commercial platform, there are what we call gears or algorithms that are installed. And as a Flywheel user, there are gears that are installed in our system that you can use freely from this, but it's not strictly developed by Flywheel. That's the open source portion of the platform. Then basically you can, between your collaborator or your people, between yourself, share some algorithm. You can also decide to share to the community if you want. And that's a way to probably have some good way of sharing. We can share the data, but we can also share the algorithm that you are developing or you want to apply to your group. And the way it's done in the platform, you would see it's structured that you have the subject, you have the images, you have the session, and it's a good way it's being structured. Keep in mind the research structure that you are used to use right now. And there's gears like HTTP pipeline, there's free surfer, there's about 50 gear now. Probably 2 years, 3 years ago, it was 10 gears, now it's about 50, and it's always evolving. And we don't necessarily control that, it's really a free sharing place where people can really share their stuff.
And these are on the exchange. I can provide a link so you can browse those algorithms that are already there, that are freely available, that we've packaged in and allowed to run on the platform. But that is also something where you want to build your own. If you want to take an existing pipeline that you're already building and working on right here, we can show you how to do that wrapping process so it's able to run on the platform. It's fairly straightforward.
Is your API always expected to be backwards compatible? So if you write a gear, it will continue to move forward without...
Yes, that is basically I can get into this in more detail, but with Docker containers, we'll always be able to run with the existing inputs. Now, those inputs are in a different spot. We'll make sure that was the backwards compatible. Yeah, so and that reproducible story is a big part of where we came from, to make sure you'd always come back and reproduce your results.
And other parts that bids coming from Stanford, I think, pretty much. This format has been developed, and if I'm not wrong, we can have image or data conversion from Dicom to bids.
Yes.
Just make sure
so
that
for those that are, I know there's James was telling us there's people already familiar with the bids specification. It is a very specific and nuanced specification that is a naming standard, and that we do provide support for both our hierarchy of data management and a conversion to the bids specification. We provide that kind of mapping from one directory structure to the bids structure. We will rely on you to understand your own data to know what it's supposed to look like in bids. But we will help you with that process of taking it from the scanner and getting into that bids format in a relatively painless fashion once you've done that work at a time to define that mapping. And I can go show how that works on the platform in a minute.
When you say we will help you, what is that? Is that
Right now we have what we define as a gear. We have basically, we'll show you how to name the scans at the scanner.
Okay.
So then the gear that will reorganize the data will use that information from the Dicom headers to inform what the bid structure is supposed to be. There are some caveats in there with like field maps and being what it's intended for. That will take a little bit more back and forth and maybe some customization on a project by project level, but that's like how we will, when I say help, that's understanding where that, how those distinctions are made is what I mean, so.
One other question there. So do
Sure.
you guys have any gears that support or simplify uploading your data to NIH's NDA archive?
That is something that is being worked on, and it's in a lot of ways. We want to not have to. Right now, we download things, and it's in our Flywheel hierarchy structure. We download or into the bids format. What we're working on is, a lot of our customers are in Google Cloud, and so we want to be able to port right from Google Cloud, not have to go down and download to your local directory and then upload, but have a direct pipeline direct to any shareable like OpenRO or anything like that, anywhere you're looking to share your data. So those are things that are in the works. I don't think we have a gear right now for that.
Basically, we put that slide there to explain that that's a choice of the customer if you want to be on-prem, it's on-prem, but we see more and more starting phase with being on-prem, but with the fact that we have access to more data and more information and the cloud advantages, you are able to scale what you need in terms of virtual machine or in terms of data. Then you don't have to forecast too much in advance about what would be the cost of the hardware. Then that's one of the advantages. But the cloud we mentioned we have a good partnership with Google, but we are open to any other cloud. In fact, we have a couple of different users in terms of cloud. It's not only Google, but we have some really good integrated tool in the Google. Then if you don't have any link with any vendor as it is, if you are looking to cloud, then Google could be great. But if you already have affiliation with other cloud supplier, then it's easy to adapt also for us.
And we also have the ability to do hybrid. The University of Penn is a good example of what we're doing right now. Their data storage is in the cloud, but they have some compute clusters that are local that are much cheaper for them that they've invested in already. That's the things that they've already spent money on. And we can integrate by sending computation jobs to that local cluster, but keep the storage costs that are cheap in the cloud. For people that are looking for on-demand computation that is paying for only what you use, the cloud is a great option. But if you have those various options, we can accommodate a lot of different configurations.
Yeah, the bottom line is we are flexible. And if it's better for you to go full cloud, we can do it. But if it's hybrid or mix or on-prem, then data is your own data. It's not our data. Then, promise, short last slides. Just some feedback from different customers that we got. We have a list of customers that we can supply, but like we have Columbia, U of Penn, Carnegie Mellon. We have about 30 sites where we are deployed. A couple in Japan, I think a couple in Europe too.
Yep.
But most of them are in the US base. And basically, those are comments from various customer or user in the last 18 months. And the highlight are kind of multi-center clinical trial imaging. It's really giving you the chance to share efficiently and to be really to keep the level of the information at the right level. There's no variation in terms of sharing the data. Productivity gain, especially at data collection, has been one of the big comments that we got. Not necessarily if you hook or not at the machine, because we can also upload using our user interface to upload images and do the de-identification from that step too. Then it's not strictly because if you are hook or not at the machine, but in general we have a good productivity gain. Data conversion format is another one too. One of the things that happens also is when people are leaving and coming in and leaving the lab, then the data is always staying at the same place, and you can find that easily, and you don't lose the track of what you're doing. Improve cooperation between lab members, and you will see at the demo when you manage the site, you can give access to the people that you want to give access, and there are different levels of access to. You can have only read, write, some rights as admin. Then this is something that is in line with some IRB rules that you want to get access, and this is something that is being very much appreciated. Yeah, also the data analysis system is really giving the chance to the user to develop an analysis here, as we explained. And yeah, this is a commercial product with open source gears, and we try to match best of both worlds. You have open source, but the commercial product means that you need to follow standards. You need to really be in line with FDA, in line with the GDPR compliance, the EPA compliance, and this is giving some security and safety on the privacy and on the patient information, health protection. And just to give you an example, also and that's a pain sometimes, but we are very flexible. We got a couple of pharma companies looking at, like I mentioned to you, like old data, and we had to turn fast in terms of adapting the software, the platform, because the requests from a pharma company versus the academic center are not exactly the same. Even if this is in the same line, sometimes how we deploy that is a bit different. Then I think over time, Flywheel customer experience team showed a lot of flexibility. For my part, and we can talk later about subscription, how it's working, but I think what I would like to do is go into the demo side, because that would be more talking than only slides, and you will have more questions coming, I'm sure, with the demonstration. You can, if you want to do it here, you can use mine if you want. Any questions, comments, worries?
So you have a subscription fee, right? That is like X amount of dollars per year to use this.
Yeah.
And what does that include? So does that include unlimited tech support and help? Or is it like so many hours of support and help? Or
The subscription, the way that we decide to do the model, it's the amount of per year is determined by the new session and exams, for example. Then we don't look at any amount of users. We don't look at any amount of year run. We really look at the new session. And basically, if you are producing like 500 or 1,000 new sessions a year, more session you do, less expensive this is per session. Then that's the way we determine the pricing. And in our also in our Flywheel platform, you can have like 3 levels of platform. Then if you are a lab and you want to get access to the full gear, then there's a price level. And if you want just to do data sorting and kind of that basic data organization, it's less expensive. Then and it's easy to, we have an Excel sheet to show you the kind of level that it's working, but it's really based on session. If you have legacy.
unlimited then support from you?
Sorry?
Or it's unlimited support from you then to.
There's a couple different levels of that kind of model. There's I think what he's talking about is there's like a core facility model that is more of your basic support. When we start getting into gear building and SDK support, that would be more like a lab edition, and those are then usually supported by a lab. So most of the time we're selling to MRI centers as the base functionality of getting the data to them, and then labs can kind of sign on for additional fee for that kind of on the post-processing side.
You see that as sort of a means for labs without indigenous program support to sort of get their feet wet, get on board, hit the ground running, or is that sort of a supplement to like indigenous programming?
So we have two different models. We have kind of like a training model of how to get you up to speed and how to use the platform, and then we have a scientific solutions team that will actually, if you don't have somebody to actually manage that pipeline for you, so that we would and that would be more of a project fee for that, and we can put you in contact with that kind of people. But
those are the sorts of things you can negotiate projects.
Yes, yeah, exactly.
Estimate hours and
we always establish a scope of work and kind of really what is involving from our side and your side. And there's a lot of flexibility on that side.
I think that's Vince's angle on this.
Yeah.
So lab would sort of like set up ahead of time a defined project with a scope of finances that would have a defined timeline. It's not just, hey, help us with everything.
Yeah,
And
and
here's our
usually-
monthly fee.
Usually we go
It's
with a
defined.
kind of a 3 years model on the subscription.
Yeah, so there's
but basically the
Writing
session is a kind of giving us an idea,
Right.
mutual idea about what will be the yearly level of fees. And in some places, from Canada, for example, it's very difficult to get money for operational budget. It's more like capital budget. Then the way that we work there, sometimes we go with a capital purchase of software. Then we include all the support and services. The main point is really to understand what is the scope of work and what is the scope of your activities. And on top of that, if for any example, after 2 or 3 years, you decide to go from basic functionality to full lab functionality, then it's not like starting from scratch. There's a differential that we can just add to go at the lab level. Then it's really basic introduction. There's a lot of discussion to get on the side of what would be the level of activities or what would be the level of thing that we need in terms of lab or core edition.
Okay. So yeah, so a lot of times that is built into scan fees in various facilities.
Very often.
But
Yeah, basically the model has been established like a small portion of the scan fees per new session to be to get in the platform as a managed data.
and as a startup, we have our business model has evolved over time. So
Yeah.
that's part of this where we've there's various things that we've been looking at is we don't want that to be a barrier for you guys to use the platform and keep using it. So
Working for a big company, I can say you Flywheel is very flexible on finding the right model and the right fit for your needs. There's no doubt on that. It's not like 500 people with a structure saying, oh, we can do that, we cannot do that. It's really a matter of understanding what you want to do with our system and what we can support in terms of years or anything else. But we have guidelines to help to figure out. Sorry, I'm good.
okay. So hi, I'm Jeff Yeager, as we said before. I've been with Flywheel for about a year now. Before that, I was with GE Healthcare, so huge company, small startup, very different. But before that, I was actually a Hawkeye, and I was part of Vince's lab in the MRF. And I noticed that Vince, you haven't changed your photos here on the website very much. There I am, right back. I want to update that. It's been a few years since I've been here. Coming back to Iowa City today was kind of a wake-up call. Like all these new buildings around here, what's going on? But yes, I was. That was back when we were still in that little corner by the bus stops in Murph there. So that was. So I've had a good time coming back today and kind of wandering around. So that was a fun Easter egg to find on the website there. But yeah, so I've been here for about a year now, and we've really kind of hit our stride as a company, and really are now focusing really on this MR neuroimaging market where we've started. It's our bread and butter. So we come in, you log in. We use various authentication services to log into the platform. It's all web-based and on the web UI side, but really it's, as Vince kind of mentioned, we have an API that you can interact with it.
That's focused on the imaging data, right? Okay.
And then the compute side is in here as well.
Right. Yeah. Oh, you're right. The distinction was between that and integration of the system with, for example, our Hawk ID and Duo and CI logon.
Yes. Yeah. So a lot of our other academic institutions use their academic logins to do it. So we have our internal emails are based on Google backed, and some institutions are also that way. I know Stanford's is all Google backed. They can use the Google Auth as well, but LDAP, SAML, Shibboleth, all these things.
That's where I was going next.
Yep, we've integrated all those so that you get use your Hawk IDs.
You have a sufficiently all singing and all dancing authenticator that can speak whatever it needs to speak.
Well, unfortunately, every academic institution has their own nuances and how those get set up. We basically will interact with the IT departments and set that up. If you're so basically the take home those, we don't store any passwords, we don't manage users and things like that. That's on your site.
You just need such and such assertions from the SHIB IEP. And
right.
Off you go.
Yep. And so it's talking to that, and then it will redirect you back to our platform here.
Okay.
So when you land here, we have the concept of we have a Flywheel hierarchy that starts at the site level, and so we have a demo site here, but if you had uiowa.flywheel.io or whatever website you had, all your data is located in the same place. Below that, we have the concept of groups. Groups in the academic settings that we deal with are typically a lab or PI centric, and that is then one way we can distinguish billing and things like that. And under each group, though, is projects, and projects is where the data starts to live. And so the data is in each of these projects. Underneath that, we have the concept of subjects and then sessions. And if I go to the sessions tab here, your data on each session is, because we come from the MRI world, would be one time in and out of the scanner. For those of you that are Dicom proficient, we based on the UID, the instance UIDs. And when the data comes in from that Reaper or connector, as we've been trying to market it now, our clinical customers don't like the word Reaper for some reason. So we've had to adjust them that way. So the data will come in, and this is the Dicoms. Dicom files come in, the loose Dicoms. We zip them up for each image because they're all there. As we consider them one image. You notice there's a little circle there that indicates that a device sent that in. There would be a little person icon that would be there if you uploaded it manually. There's several ways to do that. We have a web uploader. You're always limited by what browsers can handle when you do web uploads. We typically have a limit of like 200 megs and like 10,000 actual files that a web uploader can actually handle, but that is located here. You can drag and drop the folder of Dicom files. So if you have one MR exam or two, you probably are okay by dumping it in there. Anything bigger than that, we have a command line interface tool that you can download and use to upload and script large amounts of data to get it into the platform in bulk. Typically, that's only done if at the beginning to get in historical data, and then if you're working with collaborators that aren't hooked up to the scanner that your site is connected to. But so there's a variety of ways to get it in, and when we are looking at it, we have, again, the concept of subjects that are in the hierarchy. So everything, if I go to this view here, we have the idea that each subject can have multiple sessions associated with it. And kind of flying blind here because I can't mirror my image for some reason. But so each subject as it comes in then has sessions below it. And then on the sessions have acquisitions. And acquisitions in the MR world are separate data acquisitions with different protocols. So in the MR world, this is your T1, this is your localizer, this is your fMRI test. In other modalities, in other data gathering tools, there's still the same concept, and that's why we've named them the acquisition, session, and subjects. But because we're imaging focused, that's where we've started and where we've ended up. We've found that this actually still applies to other types of data. We have customers that will upload genomics data right next to their imaging data, and as a separate acquisition. So if you have or they will upload maybe a CSV of a form that they filled out immediately before they went into the scanner. And there's the task-based data that a lot of times fMRI users are using. That's a different acquisition. So that can sit right next to the imaging data here. Essentially, we are file type agnostic platform. We were just a file type where that distinguishes a lot from PACS, that it can only handle DICOMs. But here we can have that imaging data live right next to it, which has been helpful for a lot of users. So the one thing about our hierarchy level is acquisitions, sessions, subjects, and projects are all containers. In the sense of they are objects that have files, metadata, and other containers attached to those. And that is what you're seeing here. We have multiple files in that T1 acquisition. And we start with the DICOM files. And then there's two other types of files here. This one is a NIFTY file. Many of the neuroimaging community likes working with NIFTYs. So we need to convert the DICOM images after they come off the scanner to the NIFTY image. And we do that with the concept of gears, as Elaine pointed out earlier. So this little symbol there indicates this file was generated from a gear. And that gear was the DCM to NIFTY, so DICOM to NIFTY gear. It gives a gear version. It gives all the information of when that action actually happened. There's even more. This is just what we're displaying the UI. There's more metadata around that, which I can show in a bit. But the idea here is that we have that traceability, and then we can actually then reproduce what actually was done. When you go back and look at that project that you're working on 3 years ago, I'm like, which version did I do? Like, I just found out there's a bug in that version. All that is here. It's organized in a way you can find it, and search on it. Which brings me to what these are. So this is obviously the file type. We type a lot of our files as they come in, and we queue off that for things like our viewer. So our viewer can view. We're at the mercy of Wi-Fi here to download. Looks like we're doing okay though. So our viewers are a fairly straightforward viewer. It's web-based, obviously, so there are some limitations. We have the ability to we're starting to interface with things like Osirix and other more on the radiology clinical side. We're not quite there yet. That's in development, but that's a big demand. But this type of viewer, we can still use and do labeling with our ROI. So I can label, and this will actually persist. Yep, this is a brain, and I can save this. And now if I come back to this, that this will still exist, and you can collaborate where I can go in, make this ROI, and Elaine can come back a week later and say, yep, that looks right to me. We need to include or exclude this subject.
So is that then listed in this session or in that acquisition? So do you see derived data as well then for that?
That is a good question. Whether or not I think it is where this is stored. I'm not sure we have that viewable in the UI right now. We'd have if you query through the SDK, you'd be able to find that there's a file there that has that information. That's a good. I'll have to get back to you on that.
So yeah, and the idea of the viewer is we see more and more clinicians involved in the annotation. Then the beauty of giving access to clinician externally to be able to log in the same software. We have good comment on that because it's always a pain to get clinician involved, and if you give the right access to the right clinician to do the right stuff, then they are really happy to do that remotely. And the viewer, the idea of the viewer is we have a lot of requests about volumetric viewer annotation instead of going by slice by slice. It's kind of you have more and more images, and that's what you mentioned about Osirix or other people, because clinicians want to get something quick and easy to use based on what they know from their PACS style, and that's what we're all working on too.
So going along the terms of metadata that is on these files. So as you mentioned, that you have the file type, then you have this right here, which is our classification scheme. And we start with the modality, MR. We support all the major PET, CT, other modalities. But our MR data set for classification is the most rich, and I can show you more about that right now. MR in general has lots more levers and things to pull on how we collect the scans. And the classification is really just an elevated metadata and standardized across all of our sites. So every site that we have has the same classification scheme, and that allows site-by-site collaboration and consistency with our gears. So if you write a gear that requires a T1, you can specify that, and if you share that with another site, they can also use that same. And then the feature set here, the intent and the measurements have quite a few different classifications, and we are continuing updating this. We actually have a big update to this coming out just this coming week. And so this is kind of that's kind of standard metadata set. You can also add your own custom classification schemes. As mentioned, the reason to do this instead of a free-form metadata would be because this is something our gears, our algorithms get Q off of that is consistent. But in our custom metadata, you'll notice here, for those again that are Dicom header proficient, these are Dicom header tags. The way this is working is that as those Dicom files come in, we store those Dicoms in a zip, but before we throw them into storage, we are actually extracting and reading the header information and putting that on as metadata into our database. So that way, if you want to search, you're searching a database instead of going through each individual file, which greatly increases our efficiency on the search. So if you're making edits here, you're editing the metadata in our database. You're not editing the actual original files. And we treat those original files that are uploaded fairly, what's the word I'm looking for? Sacredly, because that's the original data. That's your bread and butter. And if we ever have an issue where you were to delete that data, we back up everything. We actually never truly delete anything unless you're asked to purge something for very specific reasons. Cold storage, especially in the cloud, is very, very cheap, and so that provides us with a lot of that traceability for our file system. So this is Dicom header information that is being pulled from that during that upload process, and it is automated in the way we have what we call gear rules. Let me pause and please stop me if you guys have any questions that you already have. But these files that we're looking at here that are run by the gears, we call utility gears, and they handle a lot of that pre-processing, metadata, file conversion. But these gears are automatically kicked off and triggered upon upload or file changes. And logic, you're customizable on a per project basis. So if you want certain thing to happen on your project and somebody else wants to have something else, we have that flexibility here built in where we can queue in here. This particular rule is looking for a Dicom file that is new. It will run our classifier that extracts the metadata off of it, classifies it, and puts that classification into the system. And you can kind of daisy chain these rules together, because this one then says, all right, now we have if you have a Dicom file and it has a classification and it's not a non-image, so if it's not a one of those reports that automatically get generated on some scanners, they'll get classified in a way to exclude those. Now you can run your Dicom, the nifty gear, automatically. So in a lot of ways, this happens while the scanner is still going. So if there isn't a backlog, our Reaper is constantly queuing the scanner every minute or so, looking for a finished scan. Once the scan is complete, it will start taking and uploading that scan to Flywheel. Once it hits, these rules and the processes start. So if you've got an hour-long scan, your first couple images will be in Flywheel already pre-processed before your last scan is done. That has been our experience with a lot of sites. So a lot of that depends on data transfer speeds from the scanner, where we're sending this to, and all that kind of stuff. But the idea is that most of the time you're at the scanner. By the time you're back at your desk, if it's not there, probably something went wrong. Give us a call, and we'll help. But most of the time, this process is very smooth and automatic, which is one of the big time efficiency savings that we see in imaging centers.
So you're saying your sessions are relatively mutable, at least enough so that as data trickles in, you can publish part of them and then update that so that what is published in the scan it reflects a later state, and then the last state you need to reflect is hopefully when the scan is done. But
yeah, so the way we're looking at it is as the Dicom files are generated, we're looking for that series instance UID, and if we check 1 minute and the same count is there that it was a minute ago, then we assume that's done.
right.
And then we'll start pulling that series instance UID. Same with the study, and really we don't ever stop. We never really close a session.
That's the critical point.
Yep.
Right, because in Dicom, if there's another one that's if you said the same thing, it's no change. It's
Yep.
not please rewrite the session.
Yes.
If you send something new, that's well, I need to update my session. Can I or can't I? And the answer is that you can.
Yes.
And
Correct.
those of us who are XNAT savvy know that that's a major improvement over some other solutions that I've seen.
Great. Yeah. So we've that is something that we treat each of these as individual acquisitions, and as I mentioned, you can add acquisitions here that aren't imaging scans per se.
Which is why I assume you used
Yes.
acquisition instead of scan.
Yep. Yes, exactly. Yeah, and that's one of the things we are looking at. We are flexible enough that we are not just an imaging platform. We really are a research data platform at its heart that really got its start in imaging that can expand beyond that based on those needs. And as long as we're talking about metadata on that session, we bring in and we put that session metadata. We bring in some of the session metadata from the scanner, the Dicom headers itself, but then we can do everything by adding our custom metadata. So if you have metadata for that subject or session that you collected that week, and then that's then transitions into search, our search capabilities. You can search in that one project that you're in, or you can actually back out and I want to search across all my projects. And I want to search for just the Nifty files because that's really all I want to be able to do. And I want to search for my T1s. I can limit the number of sessions or the time frame, or I can say I want just the males, and I want to limit the age. Nice little handy bar here. And nice that demographic. So then, but then all that custom information is now searchable too. So now you notice that there was an IQ score there that was added, and that is now searchable. And I can say I have a min and a max. I want to just do the right-hand side of the curve, and now I'm down to 2 sessions. And so I can download each of those sessions if I want from this search result. And there's also the concept of collection, which is kind of it's a hybrid of a project, or virtual project, or what I like to kind of refer to them as like a saved search result. But then you can, in that collections format, which I can show in a second, we got some pre-made. You can then share that data and work on just that data itself. Or you can actually just run a gear on these sessions straight from this search result. Alternatively, you could go and just look at acquisitions if you're just interested in acquisition, not the whole session. Or if you really just want the files, go grab the files themselves, and you can download them, and one of our Google partnerships right now is actually working with our healthcare API on doing machine learning. And what this basically does is creating a data set reference that you will be able to put into that Google healthcare API to do machine learning tasks based on a selection of data here. That's a little bit in the works and more of a tease than anything at this point. So our search capabilities are quite strong. We actually have a big improvement coming there where we have a query language, very similar to SQL, that you'll be able to use at some point soon to even have more powerful searches in that regard.
And I think this is very powerful, especially when you go with the, let's say that in the sandbox you have like 5,000 or 10,000 sessions, and you want to reuse some of the data with some selected characteristic. Then this is where the search engine is becoming really powerful. We have U of Penn and Columbia where they have a lot of session now, and this is something that is really well liked.
Could I ask then about how you anticipate integrating that with your SDKs? I mean, is there how Pythonic or not? Can you can shoot yourself in the foot, or do a very general method in like the bare REST API, and then do something Pythonic in the Python API, and then do something like that in MATLAB. I'm just curious how you see that integrating.
From just the search capabilities, or in general?
Yeah, specifically the search
Search,
capabilities.
yeah. So the search results, that's something I worked particularly with the SDK and how that works. I know that the search results come as a list that you can then act on, and I think it's like, if you're depending on what you're returning a list of containers if your sessions or a list of files in the same way. But our Python and MATLAB SDKs, which we haven't really talked about yet, interact completely with our open API. Everything you can do in the UI, you can do with our SDKs. In fact, a lot more, because you're able to script things and work.
Specifically, I was worried about do you have to? The language is presumably invented to solve a problem. Do I have to learn that language in order to perform the queries in the SDKs, or do the SDKs?
No, I mean, are you asking, can you use the open REST API directly, or?
Well, the particulars of, I mean, is this something that you say you haven't sort of fleshed it out, but I mean, this is a the language is there for a reason, right?
Right.
So.
No, okay, so maybe I thought you were referring to more like the mechanics of the actual SDK with Python itself, and I haven't interacted myself much with that. We have a team of people that are much more strong programmers than I am. I think Vince would be worried if I was our strongest programmer.
Okay,
So, but in the sense though, I think to get at your point, the SDK has a language that is relatively consistent with the idea that it's calling get number of sessions, get things like that. Is that kind of where you were headed, or?
Yeah. Okay.
Yeah. So it's very descriptive language that I think if you're familiar with Python, you'll pick up very easily, and integrating how we are interacting with Flywheel with that language, and the same goes with MATLAB.
Right.
So MATLAB is you're importing a package into your MATLAB instance and working with that data, writing your MATLAB code as you would.
And specifically, not necessarily having to imagine this in your domain-specific query language. What will elicit the results I want? Injecting that as a string into the API and getting it back. I mean, maybe there's some means of doing that. I'm just like that's.
Yeah. So I mean, I guess. Are you referring to just like if I query for a string of files and I want to act on those? You also can like bring in and download or interact with an individual container and walk through the levels of the hierarchy fairly straightforwardly. Is that? I mean,
Are you asking if it's going to stay user friendly? Or like if I have to learn Python to be able to search?
Well, no, it's sort of the other way around. I mean, there's, you know, maybe I'm trying to understand the problem the search language is trying to solve. If it's not sort of solved in a way already by the other tools and interfaces they're on.
Right. So maybe I can.
Like additional functionality is great.
I mean, maybe we can talk more about that. Maybe we can have somebody show more examples of what we can do with that. I did want to. I know we're running a little bit short on time. I do want to talk about what some of our more advanced gears. We kind of touched on that a little bit on how that would work with the utility gears. But we have a concept in Flywheel of the two different versions of the gears. And the utility gears, as I mentioned, were kind of your pre-processing file conversion, data, extraction, metadata, QA type tasks. Our analysis gears are our pipelines that are, we showed a few examples, a full suite of FSL, a lot of the human connectome pipelines are in, a lot of our customers are using those. Our analysis gears are the difference between the utility and the analysis gear is where in the back end of our product is really where the outputs are stored. Utility gears, you remember the Dicom files were in the same spot as the Nifty. So file in, file out type of operations, those are utility gears and they're stored in that same container. The analysis gears, when we do results, these are something where I'm going to maybe take multiple inputs from multiple levels of the hierarchy or across different subjects. Here's a bit larger list of some of them, and we'll make sure to distribute our full exchange list link. But if I take one of these, I'm going to be choosing inputs. So I can go through and choose through here, choose the input I want. I can go up and down the hierarchy as needed for each of these inputs. And on the configuration tab, if you're running things on a command line now, these are your optional flags that you're going to be setting. And these provide default values where appropriate. So anything that you could do running this, you can write the gear so that, and this is where when we talk about when we wrap a gear, wrap an algorithm into a gear, we're basically making it so that you can run it through the UI. Is what, so we're not changing any of the core functionality. We're just bringing that in so that we're able to access those same configuration parameters and inputs and define those inputs as you are in the running it from the command line. Finally, back into that, you'll notice there's up here there's versioning. So we do version everything as it comes in, and it's a strong version where we have you have various versions of that same algorithm on there, so you can compare and contrast results fairly straightforwardly. And as our reproducibility story goes, that you can really make sure that you can trace back all your results and rerun them and get the same results as you were before. If it doesn't go right next to where your input was, where does it go? It goes into this analysis tab. And here's an example for FreeSurfer. Actually, I'm going to, when I was here, yeah, so the AFQ demo. So here you get the results. It summarizes where those results were, all the various outputs goes, and this is where, if you're not having one file output, you're going to want them collected into a kind of an output results folder. Here, so you can go back and look at these results later. You remember remember what configurations were chosen at runtime. You can add, as any other place in the hierarchy, you can add custom information or notes to it. One more time, we have the gear information where you can go back to the source code, and directly, if you see issues, you can go directly to here. This example would be the algorithm that was written by this is an open source GitHub page where we can point you to where the science algorithm is. Our apps are all in a GitHub open source, so you can see exactly what we're doing when we wrap something into a gear. You can take these, you can modify them to build your own versions of that same gear, build your own gear, and as mentioned, that's something we can help do.
So you're saying this is sort of partly a CI system, continuous integration?
That is not exactly how that works. You're uploading your own. You have to go in and upload another version of that gear when it becomes available.
Okay, so the gear that is just the description of the data, the inputs, the outputs, and some annotations about some source I might have used to implement this.
Mm-hmm. Yep. And then finally, chose the wrong one there. This was any logs that are happening in the, if you had a terminal window that was outputting logs, those logs, okay, that's a great demo. Yeah, you did, yeah, any logs would be there. Okay. So then we can view those there in the analyses tab. Any job that was created by running a job ends up kind of in our provenance tab. It shows you everything on that session. So right now I'm selected on the session. So right here is we've done 140 jobs that have been processed. All the green check marks means everything worked great and they completed successfully. It's flagged 15 errors. So I can go find those errors now and look for, okay, I can either retry it or I can view the log, and there's their best log. Should be popping up. So this is just everything that command line would have been outputting. So you can go and look for, looks like we've got bad data input set. So that created a traceback error. And now it would say that, and this is now after this is now where Flywheel's gear wrapped into this, and we'll say this completed successfully. It's uploading the results and finishing that job as now, but being marked as in a failed state. So that gives you a lot of control and be able to dig into as you're setting up your pipelines and things like that to kind of understand what's going on at the back end of the system. With that, we are already over 2 o'clock, so I don't want to go too much farther, but we're going to hang out for a while. So
we'll be in the side around the window.
Yeah, we can either
any questions or anything.
I guess it's up to you guys if you guys need to move on or.
Yes, we started a little late, so you guys can spend say 5 more minutes.
5 more minutes. We can answer, do kind of Q&A for as long as we want. We'll stick around. So
you talked a little bit about having like the core facility and then also labs on like their own subscription or whatever.
Yeah.
I'm curious how many gears can you run from the core facility before it turns into a lab specific type?
Yeah, so it really will depend on those are kind of, I mean, maybe like you said, it's usually negotiated.
As a typical reflex, most of the time we go on the core, and when we go to core class, then it's mainly 5 gears selected, because some places you don't necessarily need to have the full lab and the full gears. And as a rule of thumb, then we go like, could be defined by utility gear mainly, or could be defined by 5 selected gear all around the main gear. Then there's a lot of potential flexibility on that. But typically there's 3 levels. It's like the core, it's like data sorting and basic queuing. Core plus is kind of average like 5 gears to be used, and full lab has all the gears available. And we go by scaling them. The 2 scaling are the amount of session and also the core lab. That it's kind of a matrix, and we can discuss that with the people.
Yeah,
The amount of sessions is new sessions, you said, not historic.
Yeah.
It's all based on new.
Historic, if for any example, we go on the side of going with new session, but you would like to have some legacy, then it's a fraction of the price for legacy study because it's a one-shot conversion that we do. And we want to give you the chance to leverage the legacy data. Then it's a service that we give at it's probably 10% of the pricing per session or per file that we are importing. And the idea is to giving the leverage of the legacy data that you want to use them. And this conversion also process that.
Yeah, and to be clear though, what we're talking about on a per session is the subscription Flywheel cost. That does not include the storage cost and the compute time cost, which if you're going in the cloud, then that is a Google cost that is can be passed on either from the imaging center. If you go to a center edition, can choose what gears they are paying for. So if they want to pay for those basic processing gears, the pre-processing, they can choose to pay for that. Then we have the ability to, if you have your own cloud project, where these analysis gears, more compute-heavy gears, the ones that don't take just seconds to run, that take hours upon hours to run, we could send them to a separate project that is billed directly to a lab. So that in that way, those costs can be passed on directly to the users that are using that functionality. And these can all be packaged into a lab edition deal, and how we structure that deal. I mean, those are, if you're on-prem, if you're using your own hardware, well, then there's whatever cost, those capital costs that, we use to run those. You lose some of the more advanced scaling capabilities when you do that, unless we can integrate with some kind of cluster system. But those are some of the considerations that it's not always just the Flywheel software cost, it's the storage and compute costs on top of that too. But we have estimators that, especially when we're talking about number of sessions, now we've got a big enough user base where we can kind of predict those costs out for you.
And you have pricing variation about cold or hot storage, and there's a lot of way to really manage them.
Yeah. And then
this is introduction. There's a lot of other discussion to come.
And we're also providing more opportunities, especially when we go into the cloud, of what kind of size VM are you using for a certain company. So if you don't really care how long it takes to run, and you want to just give it a minimum amount of time, and you're okay waiting a day or two for it to run, that's going to be a little bit less money than, hey, I really want these results today. I need a big, powerful VM to go crunch this data now. So if you're really getting into those big compute costs, we have got a customer at USC that I think was struggling at a 96 core VM that a project because they were doing a large group analysis of a large data set. So they needed a big, that was, I think, the biggest one we made. We were watching that one pretty closely to shut that down because it's pretty expensive to keep running. But yeah, so those are some of the considerations when we talk about cloud. And I think a lot of the times when we've gotten to customers, like they don't have that computer infrastructure already there. Columbia University was a great example. They were starting a brand new institute, brand new scanners in a new building, bringing in a large number of labs from around campus. And they didn't have any of that infrastructure before, so it made a lot of sense for them to go straight to the cloud, and not have to worry about buying those kind of capital equipment costs of servers and managing them themselves. This allowed them that flexibility to manage that kind of infrastructure. So,
could you talk, I guess, briefly about maybe algorithm development? How do customers go about doing integration and doing the here's a set of here's what I think is a good idea. I have a code implementation. I somehow supply the code to the place that needs to build it, and the binaries land in the place that needs to run them, and they get run, and then I look at the results, or something analyzes the results, and then I decide what to do next to improve my algorithm and things like that. How do people?
Yeah, let me see if I can't bring up a little bit. Let's see. So this is maybe a little bit more detail on the gear side. We have using our CLI gear builder tool, you can create a Docker image and import your Python script that can be executed there. And basically, you're creating your Docker image with your applications, any dependencies in the OS. We have our Flywheel infrastructure files that require are a gear manifest and an optional run script that will run through the various commands that will call the various applications, or if it's a Python script, we'll just call that script itself. That then, with your command line tool locally, you can push up to your Flywheel site and run that gear on the site, or you can run it locally to do some on local files to do some testing. But if you wanted to put it up on the site, you can have it run on the site. And essentially, what this does is the gear definition manifest, and I can send you the link to that. And you can see all the things that are spelled out in that. But essentially, it creates a config JSON file that is kind of telling the gear what to do. It specifies the inputs you've selected when you were in that UI modal. It does the work on a compute engine and puts its output in the output file. And based on if it was a utility or analysis gear, it goes back and puts that into the correct container back in Flywheel.
So I can specify things like, well, this is highly parallel. I don't need much RAM, but give me scabbing processors. Or guess what? I need 60 gigs of RAM for this, but it's parallelizable. Or I desperately need a GPU for this. And
right.
That comes in for your extra.
Yeah. So there is a little bit more going on in the background than right here. Basically, we have there
are facilities for that.
Yeah, there are facilities for that. Right now, on a site level, we are specifying the VMs on a per gear basis. So if I upload a gear, I can call out all gears that are FMI prep, for example, will get this size VM. On our roadmap very soon, as you are running the gear, you'll be able to specify, you know what, I really want to throw a lot of resources at this particular run of FMI prep, or a lab that doesn't really care if they get the results right now. They can wait a few days, can specify a smaller VM with fewer, or depending on the size of the inputs. I know, hey, I got this huge data set. I need a bigger VM for that. And you would be very soon you'd be able to specify that at runtime as a config option.
So if you're doing this, is there like a stage-based implementation that you don't have to use your, this is our warehouse? Is there something that you can test stuff out on, make it work, and then move it over?
Yeah, that is definitely something we've been running into where you're on your site. Right now, we would say you can create a separate project in Flywheel to kind of have the sandbox. Certain sites that are more on the clinical side actually will have two instances of Flywheel that will have more of a sandbox site and your production site to do more of that gear development style. We are working on making gears only where your permissions on a certain gear are on a project or a group level instead of being site-wide. So if I am a developer, I'm working on a project, I'm doing kind of sandbox stuff, I can get it working in my data. All right, now I'm going to share it to my lab group. I can give permissions to my whole lab group to run by gear, and then they can do testing. And now I want to share it site-wide, so now I'm going to give it permissions site-wide. Or now I want to publish to Exchange and let any Flywheel customer use it. So we haven't built that into the UI and the permissions scheme yet, but that's the goal, is to kind of have that kind of level. But I think if you're looking for true sandbox stuff to isolate data, that's you typically will set up a whole other site as a sandbox site for that.
I need to call the wrap up.
Sure.
So we can do other offline conversations.
Yeah.
We'd be happy to
Yeah,
ask
just
you.
around
around the
the corner over there.
Yeah.
Well, thank you guys so much for giving me a
Thanks,
presentation.